the heck of it. Oh, my favorite student. Good old Ann.
And we're live.
You're a little late. First it says identify each nuclear reaction as alpha, beta, or gamma. I'm going to do the identification first, then we'll go back and we'll fill in the blanks. 2 marks each, I guess 1 mark for the blank and 1 mark for the identification. To identify what's going on, what kind of decay it is, what we're looking at is the one that appears last. If we know it, that makes it easier. Otherwise, we'll have to do some thinking. So what kind of a decay is this number 1? It's got a beta charge. It's giving off electrons. What kind of decay is number 2? Your key is that thing right there. And the fact that the mass and the number of protons didn't change. You gave off something with no mass and no charge. What's the only radioactivity that we've been looking at here that has no mass and no charge?
Gamma.
Gamma. You can write gamma, by the way, but you know I'm a nerd. I'm going to use the Greek letters. I'm pretty sure the third one, beta, yes? Fourth one? And remember, how else can we write that alpha? We can write it as a He helium nucleus, because that's really what it is. I like the alpha symbol better because it's nerdier, but such is life. Number 5. Did the mass change? So it has to be something that's massless, which means, Kenzie, it's either beta, electron, or gamma, energy. Did the charge change? So it has to have a charge. It can't be gamma. This is a beta decay. 6, definitely a gamma decay. They gave me the chart. They gave me the particle. 7, Jessica, my angel, did the mass change? I'll zoom in so you can see bigger. Sorry. Here I have a mass of 214. My new mass is 210. Did my mass change? Say yes. Yeah. By how much? 214 to 210. By how much, folks? 4. Which one has a mass of 4? I'm pretty sure it's an alpha. Also, I noticed the number of the charge changed as well. Alpha. Number 8, I told you was an alpha. So number 8, you're going to get the marks for filling in each blank. So now let's go back and see if we can fill in the blanks. The masses have to balance. I have 216. I better have a total of 216 on this side. Well, the beta particle has a mass of 0. Again, technically not quite 0, but so close to 0, Sarah, we'll call it that. So that means my missing mass has a 216. What's my missing charge, my missing atomic number? Well, I start out with 84. That means I have to have 84 here. With a -1, what does my atomic number have to be here? Kenzie is right. 85. Now I got to go look up that element from my pink sheet. Element number 85 is AT, capital A, lowercase t. How many things did I write to fill that in? 3? We're going to go a half mark off for each one that's wrong. So it's worth 1 mark to get that, but if you get 2 of those things wrong, sorry, you get 0. Is that okay? That's how we'll mark it on the test. This one is going to be 0, 0, and a gamma ray. Half mark, half mark, half mark. Is that okay? So 0, 0, and a gamma ray? Yes? 216, 0, so I have 216 mass on the right-hand side. Hayden, my friend, that means I better have 216 mass on the left-hand side, yes? And I have, 82 minus 1 is 81 atomic number, 81 protons. Which one is that? Ti? Is that titanium? Again, I wrote 3 things, a half mark off for each one that's wrong. So if you're missing 2 or you got 2 of them wrong, you're out of luck. This was an L, not an I. It's not titanium, it's thallium. Let's make that a By the way, what I usually do, because to me as a math nerd, that looks like a 1. If it's an L lowercase, I almost always write it as a handwritten cursive L. If you ever see me do that, that's... sorry? Yeah, turns out, yes. Upside down gamma. Well played, I say. Well played. 234, mass of 4, so this must be a mass of 230. I got 91 atomic number, or protons. 2 protons shoot off. That leaves me with 89 protons. Element number 89 is actinium, capital A, lowercase c. The mass looks like it didn't change, so that must be a 0. The charge went up by 1, so this must be a -1. Hey, that's a beta. What's numbers? Oh, I wrote gamma because I was looking at the next question already. Sorry. That's a beta. I never make mistakes. Number 6 is gamma. So in number 6, particles that give off gamma radiation, their nuclei aren't actually decaying. They're giving off pure energy. So it's still going to be a mass of 24. It's still going to be a charge of 12. It's still going to be magnesium, but you can drop that little asterisk star that means it's radioactive. Mass of 4, charge of 2. It's an alpha particle. Okay, they told me this was an alpha decay, so I guess I can fill in that. That gets you 1 mark. And I guess that means, Justice, it's going to be 204, yes? And 80 what? 82, which is element number lead, Pb. Okay, so that's that page. Turn the page. So it wants us to complete the following nuclear reactions and then classify each one, I'll fix that later, as fusion or fission. Let's do the classification first. Remember, this part, Emily, you have to memorize somehow. Fission is when the atom splits, breaks apart. Fusion is when 2 atoms combine and become one bigger atom. I memorize it because I know what the word fissure means. That's a split in the earth. And when I think split in the earth, I think split in the atom. And I know when you fuse things together, when you weld things, you fuse metals together, you combine them. That's what fusion is. But I've got a big vocabulary. I don't know if you guys know those words or come up with something that works for you. I haven't figured out something with the I and the U yet, the second letter. If you come up with a good acronym or dumb way to remember something with the letter I that tells you, well, let's see, I... The word split has an I in it. The word split doesn't have a U in it. I don't know. Whatever works for you. Fission, splitting up. Fusion, I see 1 atom got bigger, went from a mass of 2 to a mass of 3. Fission, splitting up. Fission, splitting up. So 1 mark for each of those. Now let's zoom in and balance the equations. Again, the masses have to balance. You got to be a little bit careful because often you'll have more than 1 neutron and we don't write it more than once. We put a coefficient in front of it. So, Amy, my angel, on the left-hand side, what's my total mass starting out? Yes. So what's my total mass when we're done? 236. I have, this is why you want a calculator, starting with 236, I have 143, and I have 90, so I'll subtract those. That leaves me with a mass of 3 that's unaccounted for. The charge that this chain reaction, the particle that this chain reaction gives off is a neutron. What's the mass of a neutron? 1. So if I have a mass of 3 unaccounted for, how many neutrons do I have unaccounted for? And we said the most common chain reaction gives off 3, but there's all sorts of other options as well. Here, we're fusing. I have a mass of 4, so that means I need a mass of 4 over here. I have a total of 2 protons, an atomic number of 2. I got 1 proton there. I'm going to have 1 proton there, and that's going to tell me which element this is. Which element has 1 proton? Which is element number 1? This is what's going on inside the sun. 2 hydrogen atoms are fusing, and sometimes you'll get a hydrogen atom that has an extra neutron or 2. Those will fuse and turn into helium. 1 up on the periodic table. Those will fuse and you'll get lithium. Those can fuse and you can get beryllium, and you can get the first few elements from your periodic table. They all come from the stars. Let's see. In terms of mass, at the end I have 90 plus 143 plus 3 neutrons. So I'm starting out with 236. So that must mean this is a mass of 235. In terms of the number of atomic number, or the number of protons, I got 37 and 55 on the right. I got 92. There's 0 here. I must have 92 there. Element number 92 is, where are you? Uranium. This is uranium-235. Very similar to equation A, but the atoms split up in a different way into different elements. It split up into rubidium and cesium instead of xenon and strontium. Hello, hello. D, last one. I got 236. I got 106 and 3. So what's left? Let's see. 236, take away 106, take away 3, leaves me with a mass of 127. What about my atomic number? I got 92, I got 39, 0. 92, take away 39. This has to be element number 53. And element number 53 is iodine. Again, you wrote down 3 things, a half mark for each one. Half-life, full disclosure, Laura, I don't think I nailed the half-life lesson anywhere close. I'm going to be retyping that lesson over the summer, but we're stuck with what we got. A rock sample starts with 120 grams with a half-life of 24 years. How many grams are left after 3 half-lives? Hayden, how many half-lives? 3. Here's what you're going to do then. You're going to go 120 divided by once, twice, 3 half-lives. You divide by 2 3 times. Now there's a shorter way to do that. You can go 120 divided by 2 to the 3rd on your calculator. This is one of the reasons exponents come in handy. What is 120 divided by 2 divided by 2 divided by 2, or 120 divided by 2 cubed? 120 divided by 8. What do you get? 15? So after 3 half-lives, you'll have 15 grams left. What happened to the other 105 grams? Those became the daughter isotope, whatever that is. You get more of the daughter as half-life moves on. You get less of the parent as half-life moves on. B, how many grams are left after 96 years? Problem. I need to first figure out how many half-lives that is, because the first question I asked Hayden was, how many half-lives is that? He said 3. Here they didn't tell me how many half-lives it is. How many years grand total? 96. What's 1 half-life? How many years? So if I take that 96 and I divide it by 24, 4 half-lives, which means I'm not going to divide by 2 3 times. I'm going to divide by 2 4 times. Or I can go 120 divided by 2 to the 4th. I think, is the answer 7.5 grams? Okay. By the way, if you got the right answer, I'll give you full marks. If you got the wrong answer, I would give you marks for showing work. I would try and give you some part marks along the way. So it's up to you. Oh, how many grams of the daughter isotope are left after 96 years? How many grams did we start out with, Sarah, grand total? And how much has turned into how much is left of the parent? So I guess everything else has decayed into the daughter. 120 take away 7.5 is 113 take away 112.5? And by looking at those ratios, we can figure out how old this rock or this substance was. Turn the page. The half-life of friselium, a very unstable element, believe me. Because, of course, when you think friselium, you think unstable. The half-life of friselium is 7 days. What fraction will remain after 35 days? Show your work. Okay. What's the half-life? How many days? How much total time has elapsed? How many half-lives is this? Okay, this is 5 half-lives. They didn't tell me the starting amount. When they don't tell me the starting amount, what's my default starting amount? 100%, which as a decimal is 1. It's going to be 1 divided by that. Now, if they wanted it as a decimal, I would go 1 divided by 2 to the 5th power, and I get that. They said they wanted this as a fraction. Now, I will accept that number on this quiz, and I will accept that number on your test. The only issue is the provincial exam being multiple choice. They might not have that number to pick from. They might only have the fractions to pick from. How can I get this as a fraction? It's 1 over, I can actually just go 2 to the 5th, 2 times 2 times 2 times 2 times 2, and it turns out it's 1 over 32. So I'll take that. I will take 0.03, Mr. Duke. Come on, pen. Or, come on, pen. Not working? 0.03125. Not grams, that's a fraction. Or that. Okay? What's this quiz out of grand total? 2, 4, well, front page is out of 16, right? 2, 4, 6, 8, 10, 12, 14. Out of 14 and out of 2. So 16 plus 14 is that a 32, isn't it? Out of 30? 2, 4, 6, 8, 10, 12, 14. Is the second page out of 14? 2, 4, 6, 8, 10, 12. Second page out of 14, right? Yeah. First page is out of 16, right? So that's 30. And then I got 2 more. 16 and 14 can't be 20. It's got to be 30. My math is more gooder.
15.
Okay, anyways, give yourself a nice clear score at the top out of 32, please.